Hi guys, welcome to this page in the notes. Again, what we're doing is we're working on simplifying rational expressions and then finding the restricted domain values, right? So hopefully what you're doing now that you got a hang of it, you're working ahead, come on back and check your answers with me, check to see if you did it right. We've got this rational expression that I will first need to factor, eliminate GCFs, top and bottom, if I have any, and then look for the restricted domain values, what makes the denominator 0. Let's go ahead and jump right into this one, and it looks like 3y squared plus 18y, I can factor out a 3y. When I factor out a 3y, that's going to leave me with y plus 6. And then in the denominator, once again, we come across another one of these. I have a 4-term polynomial. Try group and factor. That should be your first thought whenever you have 4 terms in a polynomial. So we'll do y cubed minus 2y squared plus minus 36y plus 72. All right, so I keep the 3y, y plus 6. And now I'm looking for a GCF in my new groupings, my new pairs. Well, this one I can pull out a y squared. Leaves you with a y minus 2. Okay, no problem. The negative 36y and the 72, well, I can pull out a negative 36. Leaves me with a y minus 2. Okay, so now that I've grouped and factored, and my two factors that are left over have to be the same, and they are y minus 2 and y minus 2. I'll rewrite this now with my GCFs as a factor, and then the y minus 2s as my other factor. So I have 3y, y plus 6, all over. It's going to be y squared minus 36. And a y minus 2. All right, so now we're taking a look at this and we go, all right, we just did group and factor, but after grouping and factoring, I still don't have anything that cancels. But upon further inspection, looking at it a little closer, I recognize, and I told you it would show up over and over and over again in this chapter, y squared minus 36 is a difference of squares. You're not done factoring. 3y, y plus 6. Y squared minus 36 will factor into a y plus 6 and a y minus 6. There we go. Now I have my GCFs top and bottom that'll cancel each other out, and I'm left with, I apologize, I'm going to have to squeeze here a little bit. I wind up with 3y divided by y minus 6, y minus 2, and I normally, right, I go through the work for showing the restrictions. You just set the denominator equal to 0. I think you guys at this point can pretty clearly see that y cannot be, this one would be a positive 6, this one would be a positive 2, so y cannot be 2 or 6. All right, let's go ahead and do another one. All right, so we take a look at this guy, and let's see what we see here. Well, right away in the top, I recognize that I can pull out an x cubed. But I actually can pull out more than that. 4, 28, and 32 all have a 4 in common. So I'm going to pull out a 4x cubed. When I pull out a 4x cubed, that's going to leave me with an x squared minus 7x. Minus 8. In the denominator, again, I have a 12x cubed and a negative 768x, from which I can pull out a 12x. That's going to leave me with an x squared minus 64. Again, in the top, general trinomial. Hopefully it'll factor easily. If it doesn't, we'll have to try something else, but I think it will. And then x squared minus 64. This is the third time we've seen it. Difference of squares. You should recognize them pretty quickly when you see them. 64 is a perfect square, so difference of squares. So we're not done yet. Here we go. All right. My trinomial in the top should factor. I need two terms that multiply to an x squared. That's the easy bit, x and x. The slightly trickier bit, two numbers that multiply to a -8, sum to a -7. Well, again, that's actually not that tricky. It's going to be a -8 and a +1 in the bottom. 12x, and then my difference of squares, very easy to factor, right? It's going to be 64 is a perfect square. 8 times 8 gets you 64. So it'll be x minus 8, x plus 8. And there they are. My factors that cancel top and bottom, leaving me with 4x cubed, x plus 1, all over 12x times an x plus 8. Actually, though, not done. Not done. Watch out for this. 4x cubed and a 12x. Now, you cannot cancel through addition or subtraction. However, this 4x cubed is multiplied by the quantity x plus 1, and the 12x is multiplied by the x plus 8. That means I can reduce the 4 and the 12. I can reduce the x cubed and the x, right? I can reduce those guys. And so that's what we'll do. All right. The 4 will cancel with the 12, leave you with a 3 in the bottom. The x cubed will cancel with the x in the bottom and leave you with an x squared in the top. So 4 and 12, that reduces to a 1 and a 3. And then the x and the x cubed reduces to an x squared. And therefore, I am left with x squared times x plus 1 all over 3 times x plus 8. Right? Now, my restricted values, well, actually, again, really easy. X cannot be equal to a -8. And again, remember the way that I did that. Set the denominator equal to 0. 3x plus 8 equals 0. Right? No big deal. Zero product property lets you split them up. 3 equals 0. Well, that's just nonsense. 3 does not equal 0. X plus 8 equals 0, which means x is equal to -8, right? So that's how I got my restricted domain value. X cannot be a -8. Guys, head on over to the next page of the notes. I've got a few more of these for you to try. I'll meet you over there.